Good morning and welcome to the Q&A session 21 from the playlist of electromagnetic induction. The topic is the motional EMF, and this session is based on the session number 6 in which we have studied about this topic, that is motional EMF. Now, in the session number 6 we have studied that an EMF is induced in a conductor when it moves with a certain velocity in a magnetic field region. And because of that induced EMF and induced current is also set up. So based on that session, I have selected one question for this session which is written here on this board, and the question here is a rectangular loop has a sliding connector as shown in this figure. PQ is a sliding connector of length L and resistance R. It is moving with the velocity V as shown in this diagram, and this setup is placed in a uniform magnetic field B, which is going into the plane on the paper. So we have to find the value of the induced current, that is I, I1 and I2. So here I1 is the current which is flowing in the loop A, D, Q, PA, and I2 is the current which is flowing in the loop P, B, C, Q, P. So as per the Kirchhoff's junction rule, if I apply the Kirchhoff junction rule at this point Q, then I will be equal to I1 plus I2. This is the first equation which I am getting here. And second thing is that because of the motion of this sliding connector, and EMF will be induced in this rectangular loop, and the value of this induced EMF is equal to, I will be using the formula, that is B into L into V into sine theta. So B into L is the length of the conductor, V is the velocity of it, and V is the intensity of the magnetic field into sine theta also. Now here theta is the angle between the velocity vector and the direction of the magnetic field. Now since here angle theta is equal to 90 degree, so sine theta will be equal to 1. So the induced EMF will be equal to B into L into V. Now this induced EMF can be considered equivalent to a battery. So I will just modify this circuit by introducing one battery here like this. Now what I will do is I will apply the Kirchhoff's loop rule in the loop A, D, Q, PB, PA, and then I will apply the same Kirchhoff's loop rule in the loop P, B, C, Q, P. So first loop is A and then AD, Q, P, A. So now the Kirchhoff's loop rule says that the algebraic sum of the potential difference across all the resistive elements and the EMF sources is equal to 0. So the potential difference across this resistive element will be equal to minus I1R. Minus is the minus sign is because this point is at a higher potential and this point is at a lower potential. So the potential difference will be minus. Similarly, the potential difference across this resistive element will be minus IR, and the potential difference across this battery will be positive because the potential at this point is more than the potential at this point. So the potential difference across this battery will be positive. So this will be equal to B, L, V, and this should be equal to 0. Now if I use the same Kirchhoff's loop rule for the loop P, B, C, Q, P. So for this I will be getting another equation, that is the potential difference across this resistive element will be minus I2R minus I2R, and this will the minus IR plus BLV, this is equal to 0. So from here let us say this is the equation number 1, this is the equation number say 2, and this is the equation number 3. So from equation number 2 and 3, see BLV is equal to, from here BLV is equal to I1R plus IR, and this is also equal to I2R plus IR. So from here, if I just equate these two equations, then this IR and IR will get cancelled out, and finally I am getting that I1R is equal to I2R, or we can say that I1 is equal to I2. Here I1R is equal to I2R, so we can say that I1 is equal to I2. So this is the first relation which we have got. In fact, this is the second relation which we have got. The first relation was that I1 plus I2 is equal to I is equal to I1 plus I2. Now, from this relation, from the equation number 2, this equation can also be written as I1R plus IR minus BLV, which is equal to 0, and this equation can be written as I2R plus IR minus B into L into V, this is equal to 0. Okay, and now from these two equations, let us say this is the equation number 4 and 5. So if I subtract, or you can say if I add these two equations, then I will be getting the value as, I will be adding these two equations, that is 4 and 5. If I add these two equations, that is equation 4 and 5, I will be getting the value as R in bracket I1 plus I2, and then this will be equal to 2 IR minus 2 times BLV, and this will be equal to 0. And this is the equation which I have got after adding in the equation number 4 and 5. So here I1R plus I2R can be written as R is the common I1 plus I2 plus 2 IR. By adding these two, this will be equal to 2 IR minus 2 times BLV is equal to 0. Now I1 plus I2 here is equal to I. So IR plus 2 IR is equal to 2 BLV. So from here we can say that 3 IR is equal to 2 times BLV. Or simply we can say that I will be equal to 2 BLV divided by 3R. So the value of I is equal to 2 times 2 into B into L into V divided by 3R. This is the value of I. Now we have to find the value of I1 and I2. So here I1 and I2 are equal, and at the same time I1 plus I2 is equal to I. So here I is equal to I1 plus I2. So we have found the value of I, and here I1 and I2 are equal. So I will be substituting the value of I2 as I1. So I will simply put I is equal to 2I1, and this is equal to 2 BLV upon 3R. And now since I1 is equal to I2, so the value of once we find the value of I1, we can simply say that I2 is also equal to that value. So here I1 will be equal to, it implies that, or we can simply say that here I1 is equal to, this 2 and 2 will get cancelled out. So I1 will be equal to BLV upon 3R, and this is equal to I2 also. So the value of I is equal to 2 BLV upon 3R, and the value of I1 is equal to BLV upon 3R, and the value of I2 is also equal to BLV upon 3R. So thank you very much for joining this session. The most important point about this question is that apart from using the concept of motional EMF, we have also used the Kirchhoff's loop rule and the junction rule. अब ये क्वेश्चन का जो डिफिकल्टी लेवल है, this can be compared to the level of JEE main examination. So thank you very much again, and in the next session I will be coming up with a different topic from the same chapter, that is electromagnetic induction. So till then, have a nice day. Bye.